All right, guys, today we're going to be taking a look at special triangles. Okay, so this is still part of trig, and as a matter of fact, you can actually do special triangles with trig. The only thing is I'm not sure if on your test they'll want it in radical form. If they want it in radical form, you have to use the special triangles way, but if they don't care, you can still go trig all the way. Okay, so I'm not actually going to show you the trig because I don't want to waste any time, but it's the exact same thing we've been doing with trig. So special triangles. There are two types of special triangles, okay, and those are found on your reference sheet. All right, the Algebra 1 and of course Geometry and of course Assessments reference sheet. And it's about halfway down of one of the pages. You're going to see what it says special right triangles. You'll also notice that it says trigonomic ratios, and that's where it has, you know, the three old angels sitting on high chatting about heaven. Okay, so it actually still has it on here just in case they give this to you as well. All right, so special right triangles, we're going to be talking about two. The first one we're going to look at, actually we're going to kind of look at them both mixed together, but the 30, 60, 90 always makes a special triangle. The 45, 45, 90 always makes a special triangle. So the two special triangles are triangles that are made up with 30, 60, 90, 45, 45, 90. And they're called special right, obviously, because they have a right angle in it. All right, so you're going to need this right beside you. If you don't have this, that's okay, because what you're actually going to do is right on the back of your notes, you're going to copy that down. All right, so you're basically just going to copy this nice and big. There are only two triangles. Take your whole page. Go ahead and copy that down. Right, now that you have that, I'm just going to show you how you use them, okay? So you need to have it somewhere where you could see it. I'm going to use this because I'm writing on here, and I don't want to keep flipping back and forth. And it's very, 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 very simple. We're very used to looking opposite things. It's the same thing here. So the first thing you're going to find is you're going to look at a triangle and look at the angles. Okay, what are the angles comprised of? What are they made up of? Now, I see a 95, a 45, so the missing one has to be what? Well, you know all angles in a triangle add up to 180. So 180 minus the 45 is 135, minus the 90 is 45. So this missing angle is 45. So anytime you're missing an angle, go ahead and just find out what it is. Well, if I've got two 45s and a 90, I'll notice that that is one of my special triangles, two 45s and a 90. It's this one. What I want you to do, this is so very, very important. Your very first step is always going to be, again, to label it. All right, so what you're going to do is you're going to go, let's start with hypotenuse because we always know what that one is. Start with the 90 angle, go directly across from it. What is that? X square root of 2. So what I want you to do is find your 90 here, go directly across from it, directly across, and instead of us writing hypotenuse, because we know that what that is, we're going to write down what this is. So it's going to be equals x square root of 2. Okay, we're going to do that for the other two. So because they're two 45s, it actually doesn't matter. Pick one. 45 across from 45 is x. 45 across from 45 is x. So across from 45 is x, so that's equal to x. Across from 45 is equal to x. You're only going to use this one, okay, on the 45, 45, 90. Okay, it will not work on anything else. 45, 45, 90. All right, once you've labeled your triangle, you actually don't need this anymore. So once you've labeled your triangle, it looks like that, you don't need this anymore. So you can put this aside. And now your question is you're actually solving for what it is. If you're finding the missing sides, you need to find whatever the missing sides. I'm going to take a different color just so that you can differentiate everything. All right, I've got x equals this. I've got a equals this. B equals x. Okay, so straight away I can take a look. If I know x equals this, then if I see an x here, isn't x the same as x? So where I see x, I can now put x equals 2 square root of 2. Because I can clearly say that it says x equals 2 square root of 2. So that means it's x. That means here where I see x, now I'm going to replace x with what x is. X is equal to 2 radical 2. So where I see x, I'm going to say, so a is equal to 2 radical 2. And then obviously what's the operation between x and radical 2? Multiplication. So times radical 2. Okay, now because we've been working on radicals and simplifying and multiplying and dividing, we should be really good at this. All right. You multiply the two. The big idea is you multiply the outside, so there's an invisible one. So 2 times the outside, which is just 1, is 2. And then you multiply the insides, which is 2 times 2, which is 4. Always, 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 always simplify. All right, 4 is going to break down to 2 times 2, okay, which you can take outside as a pair, because there's a pair right there. Take that outside. What are you going to have outside? 4. What are you going to have inside? Nothing. Okay, or you can realize, so when you take it out, you say 2 times 2, so you take the 2 outside. 2 times 2 is 4. Or you can realize that the square root of 4 is actually 2, so 2 times 2 is also 4. So A is equal to 4, B is equal to 2 square root of 2, and X is equal to 2 square root of 2. Easy. All right, and this is what we're basically going to do for every single question. So you're going to go to your 30, 60. So here I have another triangle, 90 and 30. So if this is 90, this is 30, what's this missing one? Again, all triangles add up to 180, so 180 minus 90 minus 30 will give me the missing one of 60. So this is 60. All right, so it's a 30, 60, 90. Look, that is definitely one of the special triangles, 30, 60, 90. So you do the very same thing. Let's start with the hypotenuse. That's always the easiest one. Here's the hypotenuse. Go opposite that. What's that? 2x. So you're going to start the hypotenuse here. Go opposite that, and that's equal to 2x. Okay, look back on your triangle, 30, 60, 90. Let's go with 30. Find your 30 angle. Go across from 30. What's that? X. Find your 30. Go across from 30. What's that? X. So equals X. And then finally, across from 60, X radical 3. Across from 60 equals X radical 3. Once you have that down, you don't need your reference sheet anymore. Okay, you could just go ahead and solve the problem. So I have X is equal to 2, U is equal to 2X, V is equal to X radical 3. So they want to know what all this are, but not in terms of X. So I can already see that X is equal to 2. That means everywhere I see X, I'm going to put what? 2. Okay, so U is 2 times X, which is 2, so 2 times 2, which is 4. Okay, V is 2 because X is 2. So everywhere I see X, I'm going to put 2. 2 radical 3. And that's what V is. So U is 4 and V is 2 radical 3. All right, so a lot of times, in fact, not a lot of times, all the time, if we know how to multiply, divide, simplify, and rationalize radicals, the special triangles make it a lot faster to solve problems than doing whole trigonometry problems. All right, let's take a look at the next one. Again, it is 60, 90. Okay, so I think by now you already know what the third angle should be, but I'll go ahead and show you again. It all adds up to 180. So if this is 90, that's 60. You do 180 minus 90 minus 60 equals 30. So write in the missing angle, which is 30. All right, check if it's one of your special rights. Okay, so check. It is. It's 30, 60, 90. Okay, so again, pick one. We're always going to pick with start with the hypotenuse just because I'm just used to doing that. So going to go from 30, 60, 90. Across from the box is 2x. So then across from my 90 is 2x. Okay. Go to my 30 next. It doesn't matter which one you do next as long as you're going across. Go to 30. Go across from 30. That's x. So here's 30. Across from 30, that's equal to x. And finally, across from 60, that's equal to x radical 3. Across from 60, that's equal to x radical 3. Okay? All right. You no longer need your reference sheet. All right, so then we can now solve this problem. So y is equal to x. 2x is equal to 16. Oh, look, I can simplify that, right? Can I solve for x here? I sure can. What do I do to both sides? Divide by 2. So x is equal to 8. So that means everywhere I see x, I'm now going to put 8. So I see an x right there, so that's equal to 8. So y is equal to 8. I see x is equal to radical of 3. So where I see x, I'm going to put 8. So this is x radical 3. I don't touch this x because that wasn't there before. It was part of the problem. I don't like it when they actually use x and y's because it kind of confuses it. So if you'd like to think of this as, maybe let's think of this as S and T, because it's not part of the formulas. It's just something else. So I don't want you to get confused on that. All right, and basically that's what you do. Fourth question, again, find your missing angle if it's missing. So you've got 180, because it all adds up to 180. 180 minus 45 minus 90 equals 45. All right, so it's a 45, 45, 90. That is one of your special triangles. All right, so again, start at the box, across from the box, x radical 2. So box across from the box, 4 is equal to x radical 2. Okay, start from the 45. The 45s across are the same. So 45 across is x. So 45 across is x, and I hate it when they use x, so I'm just going to change this to s real quick, and t, just so that I don't get confused. That's equal to x, and across from the other 45 is also equal to x. All right, so I've got the information. Now it's just to solve the problems. Well, I can get x by itself right here, right, because there are no numbers on this one. So what do I need to do? How can I get rid of what's bothering my x? Divide by radical 2. If I divide by radical 2 on both sides. So this is going to cancel out, because the radical of 2 divided by radical of 2 is just 1. Okay, so it's just x. And then you're going to have x equals 4 radical 2. Okay, it's as simple as it can be. However, you do remember that you can never have a radical on the bottom. So because I have a radical on the bottom, I have to go ahead and rationalize it. So how do I get rid of the radical at the bottom if it's on the denominator? I multiply it by radical of 2 over radical of 2. Okay, so x equals, what's 4 times radical of 2? It's going to be 4 radical 2. And then what's radical 2 times radical 2? Okay, so it's going to be radical 4. And radical 4 is going to simplify to being, so this is 4 radical 2. Radical 4 is going to simplify to being just 2. Either you could just take the square root of 2, or you could split this up into 2 times 2. And then you've got a pair, take it outside. Okay? Now, is this as simple as it can be? No, because again, I can simplify 4 and 2. What can I divide by? By 2. Very good. So divide by 2. And then my final answer is going to be 2 radical 2. So x equals 2 radical 2. So everywhere where I see an x, I'm not going to put that's equal to 2 radical 2. That's equal to 2 radical 2. Okay, so it doesn't matter what they ask me for. I'm able to give them all of them relatively simple. All right, so questions start to look a little bit more complicated, but they are not complicated. Okay, they just try to confuse you. So I just want to introduce you to a couple of AOC questions just to make sure that you're okay. All right, so using the diagram below, what's the length of z? So where is z? Oh, here's z. So they want to know what this is. Okay. Now, if this is 90, this makes a linear pair, so that's added up to 180, so obviously this has to also be 90. All right, I'm just going to look at this triangle here. Okay, that triangle there. If this is 90, this is 45, what does that have to be? Again, it all adds up to 180, so 180 minus the box, 90 minus 45 equals 45. So this one here has to be 45. So it actually turns out that I actually don't need this. They're just trying to confuse me because they don't want to know what x is, they want to know what z is. And I have a triangle right there, and it's one of my special right triangles. It's a 45, 45, 45, 45, 45, 90, sorry. Okay, so opposite the box is x square root of 2. Opposite the box is equal to x square root of 2. Okay. All right, then opposite of 45 is x. Opposite of 45 is x, so z is equal to x. Opposite the other 45 is also x. Y is equal to x. All right, and then we solve this problem. So we are trying to find out what this is, so what x is. So if x radical 2 is equal to 9 radical 2, we're going to solve for just x. So what do we need to do to both sides? Because what's bothering my x? Radical 2. So to get rid of it, it's multiplication, so we're going to divide by radical 2 to both sides. All right, this is going to cancel, or rather radical 2 divided by radical 2 is 1. So that's just going to give me x equals, And then I have on this side 9 radical 2 divided by radical 2. Well, the radical 2's are going to cancel or simplify to just 1 because inside divided by inside by the inside, so 2 divided by 2 is 1. The square root of 1 is just 1. So 9 times 1 is just 1. Same thing here. Divide the insides, 2 divided by 2 is 1. The square root of 1 is just 1. Okay, so all that you're left with is going to be 9. So x is equal to 9. That means z is equal to 9 and y is equal to 9. So what's that answer? A. All right, so they look tougher, but they're exactly the same thing. You just got to read through what they're actually saying. All right, here's another one. Oh my gosh, there's no triangle. What can I do? Oh my goodness. If an hypotenuse is 30, 60, 90, if the hypotenuse of a 30, 60, 90 triangle is 15 feet long, what is the length of the triangle's shortest side? All right, so I clearly need a triangle. If you don't have a triangle, I always say this, the first thing you need to do is draw one. So here is a 30, 60, 90 triangle. And I'm actually going to draw it exactly as my reference sheet. That way I don't have to look too hard. So 30 on the bottom, 60 on the top. Doesn't really matter as long as you label it correctly, but I'll do it like how they did it. All right, so 30 on the bottom. Then I have an x here. I have a 2x here. And then I have a x radical 3. Bam. Triangle is there. Now let me read the question. If the hypotenuse, which one's the hypotenuse? Opposite the 90, is 15 feet. Okay, so they're saying that opposite the 90 is 15 feet, because that's a hypotenuse. What is the length of the triangle's shortest side? Now, you need to find out which one is the shortest side. Okay. Remember when we had gone over triangles, I said the largest angle is always the longest side, the second largest angle is the second longest side, and the smallest angle is the shortest. So if you look right here, the smallest one is what? 30. So across from 30 is going to also be the shortest side. So across from that, that's going to be the shortest side. So they really want to find out what x is equal to. So here's my question. 2x equals 15. So what do I need to do to both sides in order just to get x on its own? Divide by 2. The 2's cancel. So I've got x is equal to 15 over 2. So x is equal to 15 over 2. All right. I don't actually even need to find this. I really could if I wanted. If x is 15 over 2, that becomes 15 over 2 radical 3 times radical 3. And that can't simplify anymore. So the shortest side, again, always across, okay? Always across from the smallest angle, okay? We did this not too long ago. Shortest side always across from the smallest angle, which is going to be 15 over 2. Perfect. We're actually going to leave number 8 until I teach you something else, and then we're going to come back to it, because remember, math just keeps adding on. So I need to teach you properties of quadrilaterals, and then I'm going to come back and we're going to look at this problem so that we can solve it. Okay, but that's pretty much it. That's it for special triangles. If you have a reference sheet, it's easy. Again, if they don't care about the answers being in radicals, you could always use trigonometry and ask me in class, and I'll go ahead and show that to you.